This tutorial covers concentricity. To start off, open up the concentricity PDF file. So concentricity is a condition where the axis of elements are common to a specified datum axis. So in this case we're going to be needing a datum. We're not going to be using maximum material condition, and we would apply this to a cylinder type feature. Now I guess the explanation of concentricity is, we're going to have one axis that's going to be kind of like our datum, or that we're going to have off of it, and we want the part to be within that tolerance. So the location needs to be within it. So what we have, I've kind of shown, is like our GD&T tolerance. So we may have a tolerance as where that cylinder's position can be within the center axis. And then for the concentricity, I show just different positions where it could be, where it's still within the GD&T tolerance. So if you think of the axis, if you're looking directly onto a cylinder, in this case what we're going to show is we're going to have one cylinder and we're going to have another cylinder positioned inside, not inside, extruded out from it. I'll just show you quickly down below. So we're going to have kind of like two extrudes. We'll have a first extrude, which is our outer diameter, and then a second extrude, which is the smaller diameter, and we're going to apply our concentricity onto its location. So what we're trying to do is we have our original shaft, and we want the second shaft that's smaller that we're extruding to be positioned in the center of it to our specified tolerance. So if we go back up, with our concentricity, we have our GD&T tolerance, and that's how far the center point of our new shaft can move around from the initial shaft's position. So like I said before, we need to have a datum, and we're able to apply this. So to start off, the feature, again, what I said, what we're going to apply it to is the second shaft coming out, so the smaller one. So our original shaft we're going to use as our datum, so the larger one, and we're applying the datum on the outer edge there. So that means that we're going to be holding the outer shaft. It's going to be fixed in a type of fixture when we're measuring the part, and from that fixture we're going to be using the center point or the center axis of that shaft. We've applied the two diameters just to show, as well as the extrude coming out. This is just more of a pictorial, just so you kind of get an idea of what we're looking at rather than the concentricity tolerance. To do this, to define the position of the concentricity, all that we're doing is we're creating our GD&T feature. We're showing the concentricity picture. We're applying our tolerance for the diameter of where it's supposed to be, so 0.05, and we're showing the datum that we're going to be measuring it from. And using this, it is better than if we had, say, like a plus minus 0.5 going back and forth trying to position it in the center. As this, it's not just the location, but we're actually also using the original part, and from the original part we're defining where the location is of the second one coming out for its concentricity. So we would use this, again, kind of like in an example like this, where you have a shaft and you have an original axis where you want to create your concentricity from. So again, with concentricity we need our datum. We chose the outer, the larger diameter shaft as our datum to close into the fixture, and from the fixture